Hello everyone, this is the video lecture for College Algebra Math 1314 Section 2.7, Inverses. So let's learn about inverses. First off, they're going to ask for f of g of x and g of f of x. The reason why they're doing this is that if you get x for both of your answers, then you would have, or they would be inverses. You would have an inverse, but they would be inverses. They are inverses. And then you would click yes. But you have to get an x, just a single x. That's basically the formula. I guess if you want me to write it on the side, I could. So f of g of x equal to x, and g of f of x equal to x. Inverses. Okay. Well, yeah. That's fine, but I don't know if I'm even going to get inverses or not. I need to actually do the math to see, but that's what I would hope to get. And so let's actually do the math. I'm going to take this g and plug it into the x there. So 4 times, I got x minus 1 all over 4, and then plus the 1. And so these 4's cancel out, x minus 1 plus 1. Those cancel out, and indeed we just get an x. And if you do it the other way, if you take this and plug it in this way, guess what? You also get an x. And so you say yes, they're inverses, and we're good to go. So very simple. But I want to make a mention. I want to make a note here. Do you see something? Look, the 4 is being multiplied. Now the 4 is being divided. Here's something else. We have a plus 1. Now we have a minus 1. And so you can see that there are inverses here, and I'm going to make up, it's supposed to be inverses, I'm going to make up another English word for inverses, opposites. Opposites. And so plus 1, minus 1. Multiply by 4, divide by 4. There's actually more behind this even. You could see that this 1 is on the outside, and now he's on the inside with the x. Or the 4 is only with the x. Now 4 is for everybody. So inside, outside, all kinds of different opposites that we'll be seeing. And so if you kind of just see it, and you, the default would just be put an X and say yes, and you're good to go. That's fine, but sometimes it's deceiving. So number 2, are these inverses? Could I just go ahead and skip this problem, do this? I mean, they look like they had the same numbers. Well, hold on. Let's look. So I've got a multiply by 4, and now I got a whoa, plus 4? Okay, I got a minus 5, and now I have a divide by 5? I thought it was supposed to be minus plus. I thought it was supposed to be multiply divide. Got the wrong numbers in the wrong places. And so right now I could say that it's not an inverse. Right now I could say it's not an inverse. And we will not get x for these answers. But we still have to do it. And so what I'm going to do first is take this and plug it in to my x and hope that it's not going to be terrible, because nothing here is going to cancel. It's not going to cancel because it's not an inverse. All right, so we need to simplify this guy down. And of course, there's a few ways to go about doing this. I think distributing the 4 might be best right now. And so we would have a 4x plus 16 all over 5. Minus 5. I need a common denominator. And so you can multiply this side by 5 over 5. And what happens is that these 5's here combine into the numerator to make a 25 over 5. Common denominator. So now you can put all of your numerators together, all over the same 5. Combine like terms. And that should be a 9 or an 11. And it is okay to use a calculator. Yeah, it's a 9. So it's okay to use a calculator even on some simple stuff, okay? There we go. That's what I would put into part A. Whew, man. Now we got to do part B. So part B, get the right color here. Part B, I'm going to take this and plug it into the x. And so now it's going to be blank plus 4 all over 5. Of course, I need to put that in there. 4x minus 5. This one's considerably easier. You don't need the parentheses. Combine these like terms, and then you're actually done after like 2 steps. So that's your part B answer. That's what you would put there. But the point is that is not equal to x, not equal to x, not an inverse. But we already knew that. And it's okay to see that ahead of time. Just be careful, okay? Next question. It says, find the inverse. This is an inverse right here with a little -1. And so in English, it's called F inverse. That's how you say that. It's not F -1. But if you said F -1, I would understand. But F inverse is the proper English for that. F inverse. That's how you say it. So we want the inverse. And I'm just going to real quick do, I guess my version of this is kind of easy. I'm going to say opposites. And so I have a multiply by 4. Now I'm going to divide by the 4. I have a +7. Now I have a -7. And notice that he's on the outside. Now he's on the inside. Right? Or the 4 is just for the x. Now he's for everybody. You're done. There's nothing else to do there. It's very simple. You're done. Just put that in. And I wanted to make that as a point here. These problems are not hard. You can definitely do this without having to go through every single piece of math. But there will be harder problems coming up. And this is a good problem to test those formulas now so that later we'll be more prepared. And so there is a formula for this, okay? So kind of like right now, forget about everything we just did. And let's go and use a formula. I don't know if it's a formula. I think I would probably say like a system or maybe like an algorithm. Anyways, so there's steps. There's steps to getting an inverse. And step 1 is to write it as y equals. So instead of saying f of x, you want just y equals the 4x plus 7. So that's actually what we really need. So that's step 1. I know it's a silly step 1, but it's important. Step 2, you're going to switch your x and y. So wherever you see an x, you're going to put a y. Everywhere you see a y, put an x. I'll definitely show that here in a second. And then number 3, you're going to solve for y. Okay? So let's do that. So my original was the 4x plus 7. Just going to verify. Yep. Okay, we're good. And so to be able to do this, I want y equals. Makes it way easier to draw and do all this stuff anyways. And then I want to switch my x and y around. So everywhere there's a y, there's now an x. Wherever there's an x, there's now a y. And then I start to solve. So to solve this, I need to get y by itself. I'm going to -7 on both sides. So x minus 7 is equal to 4y. Divide by 4 on both sides. So y is equal to x minus 7 all over 4. And that's actually your inverse. That's your answer. Okay? So that's a little f, -1f inverse thing. Yep, and we got that earlier. So you didn't have to do all this math, but I wanted to show you because there's going to be other problems coming up where you actually do need to do this. Okay, they got more to this problem. So they're saying find out what all this stuff is. And I got to say, the homework program that you're using is sometimes a little confusing. And so we need to be able to understand what they're wanting. Well, they want the inverse right here. That's your answer. You're going to put x minus 7 over 4 right here. And then if you actually were to do this f of f inverse or f of g of x kind of thing, like questions 1 and 2, you would get x because they are inverses. They just cancel out to make an x. Same thing here. They want your original here. So your original is the 4x plus 7. And again, x verified, I guess. Verified. I think that's how you spell it. Anyways, verified. Everything's great. Cool. Next question. This one is a lot bigger. And I'm going to ask you, what's just look at this problem, right? We don't have to do the math, right? Just look at it. Tell me what the inverse is going to be. I'm waiting. I want to do this one by hand with the long formula steps and stuff because I don't know what the opposite of that thing would be. There's too many numbers. And so I need to be able to do this with all my steps. So I'm going to say now y is equal to the 9x plus 7 over x minus 4. And then I'm going to switch my x and y around. So x is equal to 9y plus 7 all over y minus 4. And then we need to solve. And that's going to take a little bit of time. So let's just kind of focus on this for a bit. I need to solve for y equals in the end. First off, there's fractions. I don't think many people like the fractions. So I'm going to multiply this so you get rid of the fraction. So you got this y minus 4. Let's just put the x in front. And then we got a 9y plus 7. Distribute to simplify x times y, 4x, 9y, 7. And at this point, this is where we need to understand where we're going. The goal is to have y equals blah, blah, blah. Okay, so that's what we need. We need y's on one side and x's on the other, if at all possible. And so what I'm going to do is I'm going to minus the 9y on both sides to get y's over here. And so then I got xy minus the 9y minus the 4x is equal to 7. And then let's get everything else to the other side. So 4x, you add them, cancel. And I'm going to put the 4x in the front because it's tradition. And now I want to get y by itself, y equals, so I think I can factor out a y here, leaving x minus 9. Last step, divide. Y equals, your inverse equals, your answer is this guy right here. There we go. We did it. That's a lot of steps. And it is a harder problem. It's one of the hardest ones here on your section, your homework section. Let me go and put this down. So 4x plus 7, and then x minus 9. So 4x plus 7, then x minus 9. Just verifying I got the thing. Yep, okay. So we put our answer in. Everything's cool. But, you know, there are always patterns to this stuff. And I almost don't want to say it, but I kind of do in a way, because math is always involving patterns. We should be looking for that kind of stuff all the time, not just to make our homework quicker, but to just understand that life is full of patterns. Look back and forth a couple times. Look back and forth. You see it? You see the opposites? I'm not going to mention it. I'm not going to say it, but I'm going to let you think about it. It's not exactly what you think, though. If you think, oh, if I just... it's not that easy. And if you were to actually do that going forward, say on your exam or something, and it's just a tiny bit different, you actually could get the whole thing wrong. So I would be very careful with this problem and still do it by hand. I do it every time by hand. But patterns are not bad. We just need to be able to recognize them. Okay. So this is kind of strange here with the domain restrictions, x not equal to. And I'm actually going to have to go back to the notes here to see exactly what they were wanting. And indeed, they want 9 here. And why is that? It's because this x minus 9 at the bottom. So do we have division? Yes. So bottom equals 0. And we want to avoid that number. That's a hole in our domain. But it's from the answer. So they're wanting that over there. After this is very simple to fill in. This is, again, my answer. So I'm just going to retype it again, however annoying that is, x. And then we got the original. So that's the original. And again, you put an x. Verified. Okay. Next question. So now they're going to talk about inverses of graphs. And what we use to find if there's a inverse of a graph is the horizontal line test, which is similar to vertical line test. But before I do all this, I'd rather just talk about it for a second, if that's okay. Inverses of graphs, let's just first off make my f here. That's going to be a square root. Inverses follow a particular pattern. They are symmetric about the y equals x line. Or I guess you could say the 45-degree line. And that's fine too. That's at 45 degrees. So they're supposed to be symmetric about that. Basically, if it's a mirror image on one side than the other. So I'm going to start here, then I'm going to swoop out, and then I'm going to touch there and swoop up there. So this is your inverse of that graph. So they're inverses of one another when they're symmetric about the y equals x line. Symmetric. Okay, so it's a little strange, and it is kind of hard to see with our human eyes at times. But again, if you got this mirror image effect along this line, you're good to go. So what I'm going to do, instead of actually following horizontal line test, I'm just going to graph these as best I can with the 45-degree line, because I think it's going to be cool. That's all. I think it's just going to be cool. On your homework, you just basically, it's all multiple choice here, and you're just saying, is there an inverse, yes or no? But I wanted to do a little bit more fanciness. Okay, so I'm going to draw the inverse as far as I can see it. Let's just say that this was 2, and so I'm going to do right here 2. Notice that we had a y equals 2, now we have an x equals 2. Didn't I just switch my x and y? Wasn't that from the formula before to find an inverse? See, there's patterns everywhere. There we go. So this red line, is that a function? Yes. Okay. What about this guy? So it looks like it comes in like this here. Does this? I don't know. Kind of like that. I know mine's a lot bigger looking, so let me try to not make it so big. There we go. Now it probably looks a little bit better. Is this red line, is this a function? Yes. Okay, what about this one now? So this one's going to be a little different. And sometimes I get it a little confused myself. There's 2 here, and so I'm going to have -2 here, and it swoops something like that. And then we're going to have a parabola shape. So if there's a parabola, it's a parabola. But I'm going to ask the red, is that a function? No. Vertical line test, I'm touching twice, not a function. Here, once, and that's fine. But here, no, it's not a function, so there are no inverses. You can't draw the inverse as a function. And the last one here, if I were to draw this, is that a function? And it's once. Even here is once. So yes, that's actually the cube, and the opposite of that would be cube root. And so those are inverses of one another. Kind of interesting to see all this stuff, but we'll be seeing a lot more of that later as well. All right, so another question here. It says, here's the function, find the inverse. And so we haven't really encountered inverses with the cube yet, but I just told you cube and cube root should be opposites of one another. So you should expect a cube root for your answer, of course, x in there. But notice that we have a -11, now it's going to be a +11, right? And it was on the outside, now it's going to be on the inside. And that is your answer, we're done. But let's go and do the formula just to make sure. And so I got y equals x cubed minus the 11. First off, I'm going to add the 11 to both sides. Oh, whoa, hold on. Switch x and y. We still will do that, but... Okay, I'm going to add the 11 to both sides. So x plus 11 is equal to y cubed. To get rid of the cube, you cube root both sides. And they just basically cancel here. So y is equal to, your inverse is equal to the cube root of x plus 11 on the inside. Hey, did we get the same thing earlier? So there you go. It says to graph both of these at once. Again, it should be multiple choice on the program, but you know, we'll try to work this out. So I'm going to use red. I'm going to use blue for my original. So I'm going to call this one blue, and then I'll do that one's red. Okay, so blue for my original, I got a cubic minus 11, so let's just call that 5, 10, 15, so there's 11, and then we got this cubic kind of graph thing here. And then for red, it would be my inverse. So notice that again, this was a negative 11 for my y. Now I should have a negative 11 for my x. Notice also right here, where is it going? It's going to the left, inside opposites, left 11. So it's somewhere over here. Then you draw this like here. And if you were to put that 45-degree line, look at that. They look like inverses, don't they? Pretty cool. The very last part of this question is strange. And they're saying find the domain of your original. So what's your domain? I'm going to ask, is there any division? Is there any square roots? I'm not asking cube roots, just square roots. And everything's fine, so negative infinity, positive infinity. And so what's the range? Well, it's kind of the same thing. It's just going to go up forever and down forever if you just look at the graph. And so there you go. They're going to ask also for the domain of f inverse and the range of this guy, but I'm going to say domain f inverse, range of f inverse. And it's kind of funny. Hold on. I don't like these arrows. It's kind of funny how they're asking it. So that's the range of f inverse. Well, notice that we have x values here and y values there. And then we switch x and y. And so my x values are now y values, and my y values are now x values. And so you just copy the same things in. If you had something different, that would be important. But they're the same things here, so we don't really care. It's just a lot of extra blah, blah, blah. Okay, last question. And this is actually pretty fun. I call it hopscotch because I'm like hopping around and jumping all over the place, but we're just going to do the math. First off, g of negative 5 is what I want to find first. So I start on the g table with negative 5, and I jump, and I find it's 5. And so I can replace this whole thing here with a 5. So f of 5 now. Well, now I need to go to my f table. There's my f table, and I start at 5, and then I jump again. There's my answer. It's a 1. So let me just redo that, recap what I did. I started with negative 5 on the g table, and I jumped over here to negative 5, to 5, just 5. 5. So now they're saying find f of 5. So I now go to the f table. So I start with my 5, and I jump over into 1. Very simple, very simple. Let me use the different colors now for this guy. Notice that there's an inverse, so it's kind of going backwards. But first off, g of 3. So g table, starting at 3, we go and we find a negative 4. And so really what they're saying is f inverse of negative 4. Now inverse means opposite, or in this particular case, it means backwards. And so you're looking for the negative 4 on the f table, but this time you got to go backwards, okay? So watch out for that. The answer would be a 7, and there you go. There's a couple other variations possible where you can start with the f table and then go to the g table. It doesn't really matter in the end. They're not hard. Just kind of hop around, skip around, and find the numbers. That's all I got. So, thank you very much, and have a great day.